Hello friends, in this lesson we are going to look at Pythagoras theorem. Pythagoras theorem is a topic in mathematics that deals with the calculation of sides of a right angled triangle. So when you're given a right angled triangle and you're asked to calculate some sides, we use Pythagoras theorem, and also we can use trigonometry. Now that's for a higher level. So for now we are only dealing with Pythagoras theorem. Okay, so here is an example of a triangle that we have here, right angled triangle. Now by right angled, we mean the angle here with this thing is 90 degrees. Okay, so the first thing is to identify the sides, especially a side that we call the hypotenuse. So what you do is you go to this 90-degree angle, the side which is opposite to this one. Opposite means very far from it. A triangle has three sides. There's AC, BC, and AB. So the side that is very far from this 90-degree angle is actually AB. Okay, so we call this side the hypotenuse. Hypotenuse. Okay, so that's what we have. And so we label these sides in mathematics by using the letters that we are using for the angles here. So for example, if you have A here, then the opposite side, this side BC, will be A with a small letter A, which represents the length BC. And then if you have C here, then the opposite side, which is the hypotenuse, this side in this case, will be represented by a small letter C. And then you have capital B there, the opposite side here will have B. And so we can write now the theory of Pythagoras, or the theorem. So the theorem of Pythagoras, there are two ways of writing it. You can use these capital letters to write it. With capital letters, it would be AB squared, which is the hypotenuse squared. The length of the hypotenuse squared is equal to AC squared plus CB squared. So AB squared is equal to AC squared plus BC squared. Or you can say AB squared is equal to BC squared plus CA squared. It's the same thing. As long as you start with a hypotenuse, then the sign in the middle there should be a plus. Or you can write this theorem by using the small letters that we have. So the hypotenuse here is C with a small letter C. So C squared is equal to our AC squared is B. So you have B squared plus A squared. Okay, so you can write it like this, or you can even swap the letters here and say A squared plus B squared. You have the same thing. So this is what we call Pythagoras theorem. This formula here is what represents Pythagoras theorem. So now let's look at some questions here. So in the first question, we have in the diagram below, PQ is 13 centimeters. So PQ there is 13 here centimeters. QR is 12. So QR is 12. And the QRP is 90. So this angle here is 90 degrees. Okay, so we have everything set now here. All the conditions are fulfilled to use Pythagoras theorem. So the only thing that we need to identify now is the hypotenuse. So since our 90 degrees is here, then the hypotenuse will be the side that is very far from that angle there, which is QP in this case. So our formula here, okay, I'll write it this side. We'll solve it from here. It says calculate the length of PR. So we are finding this length. So our formula will be the hypotenuse squared, which is PQ. PQ squared is equal to QR squared plus RP squared. So QP squared is equal to QR squared plus RP. As long as you start with the hypotenuse, you use a plus there. If you start with anything else, then that's when you use a minus. So you find this formula in so different forms. Okay, so here we can substitute the numbers we have. So QP or PQ is 13. So we're going to have 13 squared is equal to QR squared, which is 12 squared plus RP squared. So 13 squared is 13 times 13, which is 169. 12 squared is 12 times 12, which is 144, plus RP squared. And then we can collect some like terms here. 169 minus 144 is equal to RP squared. So when we subtract here, we are going to get 25 is equal to RP squared. And so now for us to get rid of this square, we have to introduce square roots on both sides of the equation. So we are going to have the square root of RP squared is equal to the square root of 25. So we just put square roots on both sides. This square root will cancel out the 2 there. You have RP is equal to the square root of 25, which is 5. In this case, our units are centimeters. And so this is the length of the side RP. So let's go to the next question. Okay, so here's our next question. So in our next question here, we have to be very careful. The question says in the diagram below, AB is equal to AC. So AB is equal to AC, so they have the same length, these two. And AD is 5 centimeters. So from here up to down here, you have 5 centimeters. BC is 24 centimeters. So from here, B, up to the end there, C, you have 24 centimeters. Okay, so we have all those measurements. And the angle ADC is 90 degrees. So we have 90 degrees here. So when we look at our triangle here, ABC, there are two triangles in it. Two similar triangles in it. There is the triangle ADB and ADC. Okay, so here's how we calculate the length of AB. So we are calculating the length of AB. Okay, so since we are calculating the length of AB, the triangle we are going to use is ADB. So since we have AD here, which is 12, and now remember one thing also, if it's 90 here, it means even this side is 90. So since we have 5 here, we need the length DB. Okay, so since the whole length from B to C is 24, and we are told to say that this line and this one are the same, so it means we are going to divide this 24 by the two lengths, this one and this one here, which will give us 12. So here we are going to have 12, even here we have 12. That's how we divide this 24. So now we have 5 here and we have 12 here. So the triangle might look like this, or will look like this. Okay, so we are going to have A here, D here, 90 there, then we have B here. And so we have 5 here and 12 here. So A, D, B, we've divided this 24 between the two sides B, D, and DC to have 12 there. Okay, so we have 12 here and we have 5 there. So we can apply Pythagoras Theorem. So what remains now is just to write down the formula. So we need to identify the hypotenuse. So our 90 degrees is here. So the hypotenuse is this side, the opposite side to 90. So we are going to write the formula starting with the AB, which is the hypotenuse. So we are going to have AB squared is equal to, the other sides you can put them in any order. So we are going to have AD squared plus BD squared. And then we can substitute our numbers here now. So AB squared is equal to AD squared is 5 squared plus 12 squared. So AB squared is equal to 25. This is 5 times 5 here, plus 144. And so we are going to have AB squared is equal to 25 plus 144. There we have 5 plus 4, that is 9. And then 2 plus 4 here we have 6. And then we have the 1 here. And so we can introduce the square root now on both sides to get rid of this square that we have. So square root of AB squared and the square root of 169. So this one will cancel with the 2 there. And therefore, our AB will be equal to the square root of 169. I showed in one of my previous videos on how to find square roots. So if you can't remember how to find square roots, go and watch that video on finding square roots. So the square root of 169 here is 13. And we have centimeters here, so 13 centimeters. Okay, so we have 13 centimeters. And now let's go to our last question. So the last question says the diagram below is a trapezium. Okay, we have so many shapes in mathematics. This one is a trapezium, the whole thing. So now we are saying calculate the length of ED. So from here up to there. So for us to calculate the length of ED, all we need is this triangle that we have this side, ECD. So the sides that we are going to need to calculate for ED here, we will need EC. Now EC is equal to AB because this is a trapezium. This length AB and EC are the same. So if it's 12 here, it means it's 12 here also. And now the whole length from B to D is 17. So from B to D it's 17. And then AE and BC are the same. So AE is 12. It means BC is also 12 here. So from B to C, we have 12. And if the whole length is 17 here, it means this one here, CD will be equal to 17 minus 12, which will give us 5 centimeters. So here we have 5 centimeters here. And so we have a triangle now with the sides that we need. So let me draw the triangle here on its own. Here is the triangle on its own. Okay, so C here, D here, we have E there. So CD is 5 centimeters. EC is 12 centimeters. So the question says find ED, and here we have 90. Now, we need to write the formula now for Pythagoras here. So we have to locate where 90 degrees is in the triangle here, and our 90 degrees is here. So the opposite side, that is the hypotenuse. So since the hypotenuse is ED, the formula is going to be ED squared is equal to, and then you check the other sides now. Okay, you can even say CD squared plus EC squared. Okay, so now we can substitute these values that we have. So ED squared, this is what we are finding. CD is 5. So ED squared is equal to 5 squared plus 12 squared. So ED squared is equal to 25 plus 144. So ED squared is equal to 169. And then now we can find the square root here. Square roots on both sides. Now, it's not always that you are going to be finding 13 as your answer, just because in our examples we've been finding 13. So it depends on the square root that you get, and whatever answer you get, you should have confidence in yourself. Thank you very much.